Hello, thank you for watching my video. Hope everybody's doing well. Doing pretty good, happy to be here. So I'm going to be explaining our first VideoCast assignment. The problem reads, a man-made lake contains 200 gallons of water with 50 pounds of a chemical dissolved into it. A solution containing 3 pounds per gallon of the chemical runs into the lake at a rate of 4 gallons per minute, and the well-mixed solution runs out of the lake at a rate of 4 gallons per minute. So the overall question is, what is the max amount of chemical ever in the lake? So, it gives us a few things about a few variables like 200-gallon lake. The important variables, a solution that's containing 3 pounds per gallon is running into the lake at 4 gallons a minute. And then the out, which will be the rate, and that the mixed solution is running out at 4 gallons a minute. Those are our main variables we're going to use. So the first part of the questions asks us to set up a differential equation modeling the amount of chemical in the lake at any time. So for my variables, I use T for time, and then a Y to represent the chemical concentration, and then Y of T would be the concentration of the chemical at time T. And then Y prime, which I'll use for dy dt, is going to be calculated as the rate in minus the rate out. So per the general mass balance equation, we know that. So we set it up in the form where we know Y prime, we get our rate in, which like we said earlier, we know the rate in, the chemical concentration is coming in at 3 pounds per gallon at a rate of 4 gallons per minute. So that'll be our rate in. And then we subtract that with our rate out, which will be the 4 gallons a minute that the mixed solution is coming out, times the overall Y over 200 gallons of the lake. So by multiplying the 3 by 4, we get the 12 over the 1. And then we do the 4Y, 4 times the Y over the 200 gallons. We get 12 over 1 minus 4 over Y. And when you simplify that, we end up with our differential equation of Y prime equals 12 minus Y over 50. Moving on to part B. Let me zoom out a little bit. Part B will simply solve the differential equation now that we have it. In order to solve this differential equation, we use the integrated factor method. So first thing I did was calculate the integrated factor, UT, which is equal to E to the integral of T over 50 dt. So we know that once you integrate the T over 50 dt, you'll just end up with E to the T over 50. And that's our integrated factor. So we want to go ahead and put it in the correct form, which would be Y prime plus PT equals QT. So we use our Y prime dy dt with our PT being Y over 50 and our QT being 12. Once we have all those variables, we go ahead and multiply our integrated factor through, which is E to the T over 50. So that gets multiplied to each of our terms. So we got E to the T over 50 times Y prime plus E to the T over 50 times PT, which is our Y over 50. And that's equal to E times E to the T over 50 times our QT, which is 12. That's what we have here. So moving down, the next step in the formula is to integrate both sides. So on the right, dy over dt, if you integrate Y prime, you just get Y. So we end up with Y times E to the T over 50. On the right side, we end up with a 12, the 12 that was on the right, times 50 E to the T over 50, where we had, and then we had to count for the constant C since we integrated the right side. All right, so moving on to calculate the C that came from the integral, we know that it comes from putting our Y at 0. So when you put Y at 0, it simplifies to 50 minus 600, which gives us a C value of negative 550. So with that negative 550, we can go plug that into the formula that we had earlier, the step before. And then we end up with, and then we divide e to the t over 50 by all the terms, which leaves us with the yt equals 600 minus the 550 e to the minus t over 50, which is e to the 550 over e to the t over 50, however you want to say it. Moving on to the last question, which solves the original question, which is, what is the max chemical ever in the lake? We know that to calculate the max of the differential, we always want to put our y prime equal to 0. So we can go back to our first differential equation. We click calculate it, which is here, and we simplify that. So y prime equals 12 over y minus 50. We plug that. So 0 is just as y prime is equal to 12 minus y over 50. So you add the y over 50 to the left, and you with y over 50 equals 12. Now, you multiply 50 by both sides, and you'll end up with y equals 600, giving you a maximum chemical in the lake of 600 pounds. And that is all I have for this. Again, I want to thank you for listening to my video today. I hope it was good enough to get a good grade. Thank you. I hope you have a good day. Goodbye. See you next time.